Write 1 plus 2i in trigonometric form using degree measure. So what's the first thing I need to do? Well, I need to actually graph this in the complex plane. So this is now going to be I, and this is going to be your real number. And it's going to come up here at this point, and this angle is going to be theta. So what I need to find is I need to find r so that I can do this. Well, how do you find r? Well, if we recall, this is the square root of a squared plus b squared. Remember, we're looking for the distance, and I know that a is 1 and b is 2, so r is going to be the square root of 5. Okay, that's great. Now what am I going to do with that? Well, if I recall, I know that a equals r cosine theta. Well, now I know what a is. It is 1. So that's going to equal to the square root of 5 cosine of theta. And then I'm going to get 1 divided by the square root of 5 equals cosine of theta. So the inverse cosine of 1 divided by the square root of 5 is going to equal to what? Well, you're going to do that on the handy-dandy little calculator, and you get 63.4 degrees. Now, what is that telling me? Well, remember, that tells me that the terminal side of that is going to pass through the point AB. So I've got AB. So the terminal side goes through there. So how do I write that? Well, remember, there's another formula that if you haven't memorized it or you don't recall, it says that z equals r cosine of theta plus I sine of theta. So now that's how we're going to get it, the original imaginary, into a trigonometric form. Well, I found r, correct? It is the square root of 5. And then I'm going to plug in what I know. Well, I know that I have the cosine of, and I found theta, which is 63.4, plus I sine of theta, which is 63.4. So this is what 1 plus 2i is equivalent to in trigonometric form.